My name's Zach Harrington.
My name's Alex Kroll, and our project is fuel injection conversion. Project background. We started with 1959 Ford F100 with a 292 Y block. The lifespan of the Y block was from 1954 to 1962, exclusively from 60 to 62 into Ford trucks. The limited lifespan of the Y blocks resulted in very little aftermarket support of these. Challenges with the 292 Y block. First is the stacked intake ports, and also again the very small aftermarket support. What's available for fuel delivery systems with the Y blocks is there's various amounts of different carburetor configurations, and for fuel injection wise, all you have is a standard throttle body injection conversion kit. Why we want to import fuel injection. First is improved fuel economy over a carburetor. Second, improved drivability. It controls throttle response and precisely injects the fuel so the engine runs at its best. Improved reliability. You never have hard cold starts. It starts right up anytime. Cylinders to cylinder control. This is the biggest one. It allows each injector to fire and control the fuel separate from each other, so you have the best cylinder control, and each cylinder gets the right amount of fuel at the right time. And improved fuel delivery because each port has its own injector. Our project goals: improve fuel economy to 18 miles per gallon. Again, with the cylinder to cylinder control, that makes this very feasible. Improve horsepower to 250. This is due to allowing the use of a larger throttle body and being able to size the injectors to your engine. And improve the overall drivability of the truck. Changes in elevation, temperature, humidity, all these affect how the fuel burns in an engine, and a good fuel injection system takes this into account and adjusts your fuel. So the deliverables for this project: design an intake manifold to accept a multi-port electronic fuel injection system. Determine a way to accurately and economically produce this manifold. We're both college students, don't have a lot of money. This is a big one. Calculate the appropriate flow rate for the fuel injectors. This is so we know we're not putting in too much fuel, allows the engine to idle right, and to make good horsepower with still maintaining fuel economy. Calculate the appropriate flow rate for the throttle body. This is so if you put too big of a one in, as soon as you touch the throttle, it'll want to run wide open. And too small of one, it'll choke the engine and it won't run right. Based on throttle body and injector sizing, calculate an appropriately sized fuel pump. This is so we're not starving injectors for fuel, not giving the injectors too much fuel. Determine the appropriate location for all sensors required to properly run the EFI. Mount the ECU to the truck and correctly wire it to the engine. Design a bracket to replace a generator to accept a GM styled alternator. This will allow us to charge and run the EFI with all the extra electrical draw. Test and tune the engine to gain the most horsepower and fuel economy. So some considerations. It had to accept common fuel injection parts. These would be stuff you can find in a junkyard, easily accessible online. We didn't want anything off the wall that would make it hard to find, and also this allows us to do other modifications down the road. Had to maintain standard hood clearance. I didn't want to cut a hole in my hood, ruin the lines of the truck, makes it look better, just makes everything work better. Had to keep stock thermostat housing location. This is big because especially starting on a cold day, you need your thermostat so the engine doesn't run too cold and it heats up properly.
Alright, this is our first design that we did back in the beginning of the semester. It's really nice, but one of the issues we ran into was actually manufacturing it. We had a hard time making the runners right here, the injector bongs, and the top plenum. And also, because of having the air come in the top, we had an issue with our flow simulations. Our flow simulations weren't running right. 4 of the runners, 4 of the cylinders got really good flow. The other 4 were choked out at full throttle. And then our next one, so this is the one that we ended up making. It was easier to manufacture. We had a lot of different models. We had a hard time right here with the thermostat and clearance with the injectors and the injector adapters for the fuel. Also, we went with a Chevy throttle body on the front side of it, and the airflow is more like a modern 1500 would. And also, we ran into issues with, when we manufactured it, we gave it to people to make these bottom plates, and they gave them back to us, and they're identical, which with the 292s, they're opposite, they're different. The bolt holes are about a ½ inch difference, so we had to re-drill holes to make it work. This is the flow sim we got from the design we had. As you can see here on this side of the projection, the flow is really laminar, really good. And then over here we have the different velocities and the mass flow rates, and they're about all the same. It's the best we could get. I tried several different ones. And also the design that we went with, we were able to get equal length runners. So the equal length runners, we were able to get equal velocity, equal mass flow, and all that. Also, we looked up, and the rule of thumb back in the day was, for your size of your motor, the displacement, you want to have the same plenum size. So our plenums, our displacement for the motor is a 292. The volume we got for the plenum was 269. That's just the plenum. That doesn't include the runners. So once we include the runners, we're going to have more volume than the motor. So we're going to definitely have enough airflow going to the motor to produce more horsepower.
So some calculations. First, we started with a fuel pump sizing. This is rated in gallons per hour. So to gain this, we started with our target horsepower, and you divide it by the constant of 10.5. So with our goal of 250 divided by 10.5, 23.8 gallons per hour is the minimum pump size. So we ordered a pump that's rated at 500. The company didn't spec us what the gallons per hour was, but due to the fact that it's rated at 500, it will allow us to run at the right flow rates. Next, we move to throttle body sizing. This is rated in cubic feet per minute, and it's based off of your maximum RPM, volumetric efficiency of your engine, and the displacement. And that's all divided by the industry constant of 3,456. So 0.8 is a good conservative volumetric efficiency for most engines, most V8 engines. So once we ran that calc, we had 632 CFM. We selected a throttle body from a 1999 Chevy Silverado 1500 that gave us a CFM rating of 650, and that will work perfectly for our project. Next, we did the fuel injector sizing. This is also based off of your target horsepower, the BSFC, duty cycle, and number of injectors. So after running that calc, we got 16.5 pound-hour injectors. You can upsize them by 50%. It is allowable. So we're using a standard 19-pound-hour injector from our donor truck, Dodge donor truck. So those will work perfectly for our application. Some of the project hurdlings. Dimensioning required clearances due to head width, thermostat housing, plenum, runners, injectors, all that stuff. It was really difficult. It was take a lot of work in SolidWorks, drawing assemblies, measuring off the block, the heads. Next hurdle was machining out all the required parts. This required a lot of effort from the machine tool class, the freshman class, senior class. Motorsports helped us out, even Professor Martinelli's classes allowed me to come in and use their machines a little bit. Making enough room for all the sensors and required parts. In the front of this intake, there's a lot going on, a lot of wires, a lot of tubes, a lot of hoses, and they all had to fit together. One of the largest hurdles we had to clear was upon reassembly of our engine, the block was cracked due to misassembly. That required us to find a new engine. It put our project in a tailspin, and it took us a week to find one. So our parts list. First we started with the Fast Easy FI system. It's a universal multi-port retrofit kit. It has the ECM wiring harness for GM style sensors, and it self-learns. It helps a lot with tuning, all that stuff. Our throttle body, like I said earlier, is off of a 99 Chevy 1500. Came off of a 5.3 liter engine and will fit perfectly for our 4.8. We have 19-pound-hour Dodge injectors. And then the Fast Easy FI fuel pump and regulator kit. This communicates very well with Fast ECM and allows the computer to regulate that fuel pump. These are our works cited for our project.